Hello everyone, welcome back to Mathematics. So today's video will focus on lesson 16, everything you need to know on binomial distribution. Before we go into binomial distribution, let's understand what is probability distributions, right? So these distributions helps us to find probability from experiments. Okay, so it can be any kind of experiment. For example, let's say we have a pencil box and we need to find the probability that we can obtain a blue pencil from that. Right? So these kind of experiments, we can use the distributions to help us find the probability or the chances. But for binomial distribution, it will only focus on some certain experiments. Okay, so those experiments are experiments with two outcomes only. So, for example, heads or tails, pass or fail, win or lose. And then these experiments will be repeated multiple times. So let's look at some of the question examples here. So the first one is find the probability to obtain one head if the coin is tossed 3 times. So if we toss a coin, there will be two outcomes, right? Either it's heads or tails. So for this example, we will toss the coin 3 times, 1, 2, 3, and we find the probability where we obtain exactly one head, right? Another example is find the probability to obtain 3 ones if the dice is tossed 4 times. So I understand that if we toss the dice, there will be 6 outcomes, but sometimes the question will tweak a bit, and to make sure there will be only 2 outcomes. So for this example, the outcomes would be either we get 1 or we did not get 1. Right? So for this example, we will toss the dice 4 times and we find the probability or the chances that we can get exactly 3 ones. Right? So later on, I will explain how do we find the probability for both examples. But before that, I would like to explain one of the terms, okay, which is experiment with 2 outcomes. So notice I take out the S, right? Because experiment with 2 outcomes, it can also be represented as Bernoulli trial. A Bernoulli trial. So for example, if we repeat 3 times, it will be known as 3 Bernoulli trials. Okay, so these trials is actually trials with 2 outcomes lah. So to find probabilities, you will have 2 ways. So the first way is to use the formula, which is this given in the formula sheet. But there's another way that I will explain in the next video. Alright? So here, let's understand what is R and PQ. Right? 4 unknowns. So the first unknown is the number of successes. So if we use this example, the number of success would be 1 because we just need to obtain 1 head, right? For N is the number of trials. So here would be 1, 2, 3. So our N is 3. And P is the probability of success, and Q is the opposite, which is probability of failure. So Q will be equals to 1 minus the success probability to get the failure probability. And this also means that if we add P and Q together, it will be equal to 1. So let's look at the first example here. Before we go into examples, let's determine our X. Okay, what are we focusing on here? And what is our stance? Our stance here is we need to focus on the number of heads, right? We just focus on number of heads, not the tails. So here, we will put P equals to X equals to our number of success is 1. Okay, and then we just substitute the values inside here. So N will be 3, then C followed by the R, which is 1. Then we need to multiply the success probability. So assuming that this coin is fair, meaning for heads and tails we have the same probability, so we will multiply 1 over 2. And since we need it to succeed 1 time, so we just multiply this 1 over 2 1 time. And for Q, it's probability of failure, so it's 1 minus 1 over 2 and we need it to fail 2 times, right? Or meaning to get 2 tails, because we just need 1 head only, right? So we multiply this 2 times, or 3 minus 1. So by putting this into the calculator, you will get your answer, which is 3/8. And for our next example, the x will be number of ones, because we are focusing on getting ones, and we need to find the probability that our x will be equal to 3, because we need the probability where we get 3 ones. Right? So using this formula, our n would be 4, because we repeat 4 times, followed by a c, followed by r, which is 3, and we need to multiply the probability of success. So for this one, assuming that this die is fair, meaning same probability to get any side, right? So it's 1/6, and we need to succeed 3 times, so we multiply this by 3 times. Okay, and then the probability of failure will be 1 minus p, or 5/6, and then we need to fail 1 time, right? So it's 4 minus 3. So our probability would be 5/324. And another thing to know is that for this kind of experiments, we can actually find the mean, variance, and the standard deviation, right, using these formulas. So for mean and expected value, we just multiply n with p. So for example 1, it will be 3 multiplied 1/2. So the answer is 1.5. So a lot of students will question, what does this mean? What does 1.5 mean? Right. So let me explain. Let's say the first time when we do this experiment, we toss 3 times, and the answer we get is, let's say, 2. And then we repeat this experiment again, toss 3 times, and the result we get is, let's say, 1. And we repeat it a lot of times. So let's say sometimes it's 3, sometimes it's 2 again, 1 again, sometimes 0, 1, and so on. So the average of all of these values is 1.5. So meaning most of the cases we would get 1 head or 2 heads. Alright, so for variance, we just need to multiply another q. So it will be 3 times 1/2, 1/2. So this variance is actually the differences between all of these numbers. So the larger the variance means the differences between the numbers will be bigger. And for standard deviation, it's actually the square root of variance. So for the variance formula, we just add a square root. And for the next example, our n would be 4 and our p would be 1/6. So this one would be 0.67. Right, so this means if I repeat this experiment again, let's say I get 0 once. The second time, let's say I get 1. The third time, if I repeat again, maybe I can get 4, and so on. So the average of all of these numbers would be 0.67. So meaning, in average, I can get either no ones at all, or maybe if I'm lucky, I get 1. Alright? For variance, would be n multiply p multiply q, so 4 times 1/6, 5/6. Okay, and then for standard deviation, we just add a square root. For this part, I'd like to share what are the